In this problem, I need to find the exact value of the sine of 2 theta, and we know that the cosine of theta is equal to the negative square root of 6 over 3, and that theta is in quadrant 2 because theta is between pi over 2 and pi. So what I'm going to do first is I'm going to look at theta being in quadrant 2 and say that that means that the x value has to be negative, x is less than 0, y has to be positive, we know that, and r is also greater than 0 because r is always greater than 0. Okay, so now that's going to help me identify x, y, and r for this problem. So we know that x is the negative square root of 6, and we know that r is 3, and that leaves y. So I can find y using Pythagorean theorem, as we always do, and so I take negative square root of 6 and square it, plus y squared equals 3 squared. And when I work this out, I get 6 plus y squared equals 9, which means that y squared equals 3, and that means that y equals either plus or minus the square root of 3, but I know that y is positive because we're in quadrant 2. So that means that y has to be the positive square root of 3. And so I put that in for y. So now that I've got that worked out, I'm going to take out my Pythagorean theorem stuff. And now I can identify the sine of 2 theta. So I know from the formula that the sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta. And this is a formula that you need to know for the exam. It will not be given on the exam. So 2 times the sine of theta is y over r, that's square root of 3 over 3. And then cosine of theta, of course, was given at the beginning of the problem, so I'm just going to copy it from there, negative square root of 6 over 3. And once I work this out, then I have, negative 2 times the square root of 18 all over 9. Now, I have to make sure that this is simplified. Square root of 18, off to the side, I can do this. 18 is 9 times 2. 9 is a perfect square that comes out as a 3, and the 2 stays in the radical. So that means that I have negative 2 times 3 square roots of 2 over 9. And then I'll just go ahead and simplify a little and make a little space here. This equals negative 2 times the square root of 2 over 3. Final answer. Next, I'm going to find the exact value of the cosine of 2 theta. And we're still using cosine theta is the negative square root of 6 over 3. This is a little bit more complicated than the sine because there are 3 formulas for the cosine of 2 theta. So let's take a look at those. The cosine of 2 theta is equal to cosine squared theta minus sine squared theta, or 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta. So these 3 formulas are all equivalent to each other. So how do you decide which one to use? Personally, I like to do this the easiest way possible, and so I didn't even need to do all this work if I use the second one, because they told us the cosine of theta. So if I use 2 cosine squared theta minus 1, I don't even need to know about the sine of theta. So I'm going to go ahead and use that one. So cosine of 2 theta equals, and I'm going to take 2 times the cosine of theta, which is negative square root of 6 over 3, and we square that and subtract 1. Okay. And so I get 2 times 6 over 9 minus 1, and this is 4/3 minus 1, and 4/3 minus 1 is 1/3. There you go. So that actually worked out easier, and it wouldn't have mattered if I had found the x, y, and r first or not, because I didn't even use the value of y that we found in the last problem. So that's the cosine of 2 theta. Next, I'll find the exact value of the tangent of 2 theta for this same problem. In the previous 2 problems, we found the sine of 2 theta and the cosine of 2 theta. So while there is a formula for the tangent of 2 theta, I can also calculate tangent of 2 theta extremely easily, simply by saying the tangent of 2 theta has to equal the sine over the cosine. So I'll just make this negative 2 square root of 2 over 3 divided by 1/3, and that gives me negative 2 square root of 2. Boom, done. Now I'll calculate the exact value of the sine of 1/2 theta. Now when we're working with half angles, the tricky thing is that the plus or minus may change depending on what quadrant it is that we're talking about. So because we know that we're starting off with an angle in quadrant 2, what we want to think about is where is half of that angle going to end up? So if theta were as much as pi, then half of that would be pi over 2. And if theta were as small as pi over 2, half of that would be pi over 4. So either way, because we know that theta can't actually get as large as pi, in the problem they tell us this. It says that theta is between pi over 2 and pi, but there's no equals here. So now in this problem, I need to find the sine of 1/2 theta. And when I'm working with the half angles, I have to keep in mind what quadrant it is that we're talking about. I know that theta in this problem is in quadrant 2. Well, if theta is in quadrant 2, and that means that it's somewhere in between pi over 2 and pi, then half of theta is going to have to be in the second half of quadrant 1. And how do I know this? Well, if theta is between pi over 2, I want to know where half of theta is. I'm just dividing everything by 2, and that means that theta over 2 is between pi over 4 and pi over 2. And so that's the second half of quadrant 1. And since theta over 2 is in quadrant 1, that tells me that the sine is going to turn out to be positive. So I'm going to go ahead and take out the plus and minus there, and I know my answer is going to be a positive. Right, so now I can just plug into the formula, and sine of 1/2 theta is 1 minus the negative square root of 6 over 3, and then I'll put that all over 2 and take the square root. And go ahead and simplify that, just using algebra, or arithmetic really. And I get 3 plus the square root of 6 over 3 divided by 2. So that just means my denominator is going to be twice as big. I'm going to make that a 6 here. I'm running out of space. I'm going to do 2 steps in one there. So that's my final answer for the sine of 1/2 theta.